In this video, I'll be solving question number 1, 2, 3, 4, and 5 of atomic structure of class 11th chemistry. If you want to watch a specific solution, you can skip the video and go to that part. So let's start now. Question number 1. In question number 1, we have first part, calculate the number of electrons which will together weigh 1 gram. So let's do this quickly. Mass of electron is E and minus mass of electron is 9.1 into 10 to the power minus 31 kg, or I am converting it to gram because I have to find number of atoms in 1 gram, I think. Yes, in 1 gram into 10 to the power minus 31 into 1 kg, I have 10 to the power 3 gram equal to 9.1 into 10 to the power minus 28 gram. This is the weight of 1 electron. So now in 1 gram, I'm using unitary method so that you can understand it well. So 1 electron, 9.1 into 10 to the power minus 28 gram. So for 1 gram, I will have, see, I will transpose it here, it will go in division. Okay, so 1 gram, 1 upon 9.1 into 10 to the power minus 28 electrons. On calculating this, I will have 1 upon 9.1 into 10 to the power 28, which is equal to 0.109 into 10 to the power 28, which I will have 1.09 into 10 to the power 27. So this is our answer. 1.09 into 10 to the power 27 electrons. Question number 2 says calculate the total number of electrons present in 1 mole of methane. So methane, it is CH4. This is a molecule of methane, and number of electrons, yes, number of electrons. Carbon has 6 electrons. 1 hydrogen has 1 electron, so 4 hydrogen will have 4 electrons. Total electrons in 1 molecule of methane, I will have 10 electrons. The question is asking for the total number of electrons present in 1 mole of methane. So for 1 mole of methane, I will have 6.022 into 10 to the power 23 molecules of methane. Okay, so 1 molecule has 10 electrons. 1 molecule has 10 electrons, therefore 1 mole molecule will have 6.022 into 10 to the power 23 into 10 electrons, which will give me 6.022 into 10 to the power 24 electrons. It was as simple as that. Let us move to the second part now. The second part says find the total number and the total mass of neutrons in 7 milligram of carbon 14. Assume that the mass of neutron is 1.675 into 10 to the power minus 27 kg. So I have carbon 14. What I have to find? 7 milligram total number and total mass of neutrons. Okay, so number of neutrons, we know that carbon has 6 protons and its mass number is 14. So 14 minus 6, I will have 8. So there are 8 neutrons in 1 atom of carbon 14. So we have been asked for 7 milligram of carbon 14. Since its mass number is 14, I will have 14 gram of carbon 14, 6.022 into 10 to the power 23 atoms. Okay, so 1 gram I will have 6.022 into 10 to the power 23 divided by 14. 1 milligram, I guess 1 milligram equals to 10 to the power minus 3 grams. Okay, so this will go here in divide, and since it is 10 to the power minus 3, I can take it up as 10 to the power 3. 1 milligram, 6.022 into 10 to the power 23 divided by 14 into 10 to the power minus 3, and I can take it up as 10 to the power 3, which will give 6.022 into 10 to the power 23 plus 3, which is 26 divided by 14. This is 1 milligram. In question we have been given 7 milligram. So 7 milligram, for 7 milligram I will multiply both sides by 7, here also by 7. 6.022 into 10 to the power 23 divided by 14. No, it was not 23, it was 26 into 7, and we will have 2 in the denominator. 6.022 divided by 2 into 10 to the power 26. Yes, that's what we are left with. That will be 3.011 into 10 to the power 26. What? 10 to the power 26. Yes, we were finding neutrons. This is the answer of part A. Then part B is asking for the total mass of neutrons in 7 milligram of carbon 14. This is the total number. So in the question we have been given 1 neutron 1.675 into 10 to the power minus 27 kilograms. So to find the mass of this many neutrons, I will multiply it. 3.011 into 1.675 into 10 to the power minus 27 into 10 to the power 26 kilogram. I will have, let me calculate it very quickly. Okay, so I am rounding off it to 3. I will have 5 3 is 15 into 10 to the power minus 1, which will be equal to 0.5025 kilograms. 0.5025 kilograms. Keep in mind that I have rounded off, so the answer might not match with these decimals. You can calculate it by yourself. So we are done with the second question, I guess. No, there are more, so let's move ahead. Part 3 of question number 2 says find A the total number and B the total mass of protons in 34 milligram of NH3, that is ammonia, at STP. STP is standard temperature and pressure. Will the answer change if the temperature and pressure are changed? This is an additional question in this. So let us start. Total number of protons in NH3. NH3. Number of protons in nitrogen, we have 7 protons, and in hydrogen we have 1 proton and 1 electron. So for 3 hydrogen I will have 3 proton. So in one molecule of ammonia I will have 10 protons in 34 milligram. So I think this is similar to the first part. No, second part. Yes, it is very similar. So I will use that only. So the molecular mass of ammonia is 7 to the 14, 14 plus 3, 17. Therefore 17 gram of NH3 will have Na atoms, that is 6.022 into 10 to the power 23 atoms, not atoms, molecules. Okay, so 1 gram I will have 6.022 into 10 to the power 23 divided by 17. So 1 milligram I will have 1 milligram is 10 to the power minus 3 gram. So minus 3 from denominator will go up and will become 3. So I will have 6.022 divided by 17 into 10 to the power 26. In question it is asking for 34 milligram. So I will have 6.022 divided by 17 into 34 into 10 to the power 26. So this goes by 17 ones are 17 twos are 34. I have here 12.044 into 10 to the power 26. These many protons are there in 34 milligram NH3. Total mass of proton is similar to mass of neutron, but I'll take it as this is the answer of part A. For part B I will have mass of 1 proton 1.6 into 10 to the power minus 27 kilograms. So for these many neutrons I will have 1.6 into 12.044 into 10 to the power 26 into 10 to the power minus 27 kilogram. So let me calculate it very quickly. So I will have 19.2704 into 10 to the power minus 1 kilogram, that is equal to 1.92704. Is that correct? Yes, it is very correct. 1.92704 kilogram. This is the answer for part B. Now let us move on to the next part or next question. Before moving on, there is an additional question. Will the answer change if the temperature and pressure are changed? Okay, let's see. The total number and total mass of protons in 34 milligram of ammonia. See, ammonia is a gas. Let it occupy this much volume at STP and this much volume at any other pressure. But in the question it has been mentioned total number and total mass of 34 milligram of ammonia. If this is 34 gram of ammonia, 34 milligram of ammonia at STP, and let it be 34 milligram of ammonia at any other temperature or pressure. It does not matter to us how much volume it is occupying, because all what we are concerned with is with mass. I hope you understand this fact. So the answer will not change if not at STP. So yes, let's move on to question number 3. Question number 3 says, how many neutrons and protons are there in the following nuclei? So So in carbon 13 and 6, atomic number is 6 and mass number is 13. How many neutrons and protons? So we know that atomic number is number of protons. So atomic number is here, it is represented by Z. So there are 6 protons in this carbon 13, and 13 minus 6 we have 7, so there are 7 neutrons in this atom. Next, oxygen, it is normal oxygen. So this has again 8 protons, and 16 minus 8 equal to 8 neutrons. Then for magnesium, 24 and 12, again it will have 12 protons, and 24 minus 12 neutrons, that is 12 neutrons. Then I have iron, 26, 56. So there are 26 protons, and 56 minus 26 equal to 30 neutrons. Next, it is given strontium, 38, 88. So number of protons is 38. Number of protons is same as atomic number, and number of neutrons is 88 minus 38, which is equal to 50 neutrons. Okay, so we are done with this question. Now let's move on to question number 4. Question number 4 says, write the complete symbol for the atom with the given atomic number Z and atomic mass A. Write the complete symbol of atom. So atomic number, first I have atomic number 17 and mass number 35. So this would be chlorine, atomic number 17. Next I have atomic number 92 and atomic mass 233. So atomic number 92 is possessed by uranium, symbol U, 92, and atomic mass 233. And now part third, Z equals 4, A equals 9. So 4 is the atomic number of beryllium. So we are done with question number 4. Let's move on to question number 5. Question number 5 says, yellow light emitted from a sodium lamp has a wavelength of 580 nanometer. Calculate the frequency nu and wave number nu bar of yellow light. So lambda has been given, what it is, 580 nanometer, 580 into 10 to the power minus 9 meter. What do I have to find? So wave number which is nu naught is equal to the reciprocal of wavelength. So I will have 1 divided by 580, unit I am keeping nanometer, so I don't have to write. This is 0.0017 nanometer, that is 1.7 into 10 to the power minus 12, 10 to the power minus 12 meter. 1.7 into 10 to the power minus 12 meter is the answer for wave number. Now we know that lambda equals c divided by nu. Lambda we have been given, nu we have to find out. So nu will be equal to c divided by lambda, which is equal to 3 into 10 to the power 8 divided by lambda. I will be taking it 580 into 10 to the power minus 10 to the power minus 9. Okay, this I will have 0.0051 into 10 to the power 8 plus 9, that is 17. That is 1 2 3 5.1 into 10 to the power 1 2 3 14. So this is the frequency of yellow light of wavelength 580 nanometer. So thank you for watching this video. I hope your doubts were cleared. Further questions are available, you can see them. Till then, goodbye.